are you, my friends? This video is presenting the last part of this 70 old exams review questions, Group E, questions 57 to 70 for the complete algebra course 1 to 39. Now, question 57, find the sum of all the solutions of this equation. This is absolute value equation. We have to rearrange it, take x over 3 on the other side, and then we can say the absolute value is equal c or k, then it will be plus or minus k. So x squared minus 12 over x is equal plus k or minus k. Now, here we rearrange the equation, cross multiply. This one cross multiply. In the first one, we get x squared is 9. Second one, x squared is 18. Take the square root of both sides. In each equation, we have 4 values for the x. We must check. See, the absolute value here should be positive, and we have x over 3, and there is a minus. So only the negative solutions are accepted. Why we check? Because c contains variable. C is the value on the right side here, minus x over 3. So I take the negative here, I take the negative there, and then I add them. And I cannot continue here. I cannot simplify more. Minus 3 square root of 2 is the sum. You see, we need the sum, and there should be negative. Now, find the sum of the real part and the imaginary part of this complex number here. All this complex number, we have to write it in standard form, like a plus bi or x plus yi. Then we take the real part and the imaginary, we add them. So here, be careful. Square root of minus 1 is I mentioned before. Square root of minus 25 is 5i. This one, cube root of minus 8 is a real number. So that's minus 2. And there is I in the question. Remember that. Here we multiply normal, or you can take a minus to make it, it looks like the formula, because 2i plus 1, 1 plus 2i. 2i minus 1, I can take minus out and put it as 1 minus 2i. So these are conjugates now. So I leave the minus there, then this becomes 1 squared plus 2 squared. This is a sum of 2 squares. Square root of 36 is only 6, positive real number. 103 divided by 4, the remainder is 3. And we know I cubed is minus I. See, the minus I, and the I becomes plus I. So when you simplify everything, you get minus 5 minus 2i over 1 plus I. We have to multiply by the conjugate of the denominator up and down, and then you multiply until you get minus 7 over 2 plus 3 over 2i. The real part is only this one, and the imaginary part, 3 over 2 without the I. Remember, the imaginary part only 3 over 2. So when you add them, minus 7 plus 3, this is the same denominator here. Minus 4 over 2 is minus 2. Now this is a medium question. Graph the function, piecewise function. We have minus x squared plus 5, x less than or equal to 0, minus absolute value of x if x is greater than 0. Then we answer, where does the graph lie below the x-axis? Just take piece by piece. The first one, this is a parabola here, see, less than 0. So all the negative until 0. Minus x squared, so this is a reflection in the parabola, plus up 5 units. See, this is part of the parabola. You see that blue? Part of the parabola here. X less than or equal to 0, so this is closed here. If you need the x-intercept for this parabola, put y0. See, y0, you get x squared is equal 5, so x plus or minus square root of 5. So we have here in this number here, minus square root of 5. And this one is v, you know the v? But there is a reflection minus, so it's v reflected only in the positive x and open. So I say open and only this positive x greater than 0. So where the graph below the x, below the x here from minus infinity until this number, And this number is exactly the x-intercept, so minus square root of 5 union from 0 below the x until infinity. Given the functions f and g, find the domain of f circle g. We have done similar maybe. So I have to replace all the function g in the f, because f circle g means f of g of x. So I replace g, x plus 18, inside the f. So x plus 18 minus 8, and then 30 minus, there's a bracket, x plus 18. We have this function. Now I know I have a radical up here, x plus 10. It should be the radicand greater than 0 to make sure all the numbers under the radical positive numbers. So closed from minus 10 to infinity, leave that one. Down also here, there is a radical square root of 12 minus x. Also the radicand should be greater than or equal to 0. So x will be from minus infinity to 12. Now remember, the denominator cannot be 0 here. There's a little trick here. 2 minus square root of 12 minus x cannot be 0. So take 2 on the other side, square both sides. X cannot be 8. So if you put 8 here, you get 0. So we have to exclude that from the domain. So the domain will be domain of g. See, g is a linear function here. X plus 18, domain is R. So in g, domain of g intersection with the domain of f circle g will be minus 10 closed to 8, union 8 to 12. Now complex numbers again, z1 is equal to square root of 9 plus I, and z2 cube root of 8 minus I. Now we simplify each one. This one is a real number, square root of 9 is only 3, and cube root of 8 is only 2. Now, if z, so we have another complex number, z will be z1, z2, you multiply them, minus z1 times z1 bar, the conjugate, divided by the subtraction here, z1 minus z2. When you finish z in standard form, find the value of z times z bar. It's not that difficult. So you put 3 plus I, 2 minus I, you multiply. Here multiply by the formula Z1, Z1 bar. Here we subtract until you get minus 3 minus I over 1 plus 2I. Multiply by the conjugate. In the numerator, we multiply by the FOIL method. Here by the formula, 1 squared minus 2 squared, that's 5. So now Z is minus 1 plus I. Find the conjugate, minus 1 minus I. When you multiply by the formula, it's a squared plus b squared. So minus 1 squared plus 1 squared. If you want to multiply normal, you can use FOIL method. You will get the answer 2. Now question 62 will be find the product of all the solutions of this equation, x squared minus 3 all squared plus 27x squared minus 3 is equal to 28. It looks like this equation is quadratic in form. So we can change the variable here. We can say let y is equal to x squared minus 3, just to make it easy, because this is power 1 here in the middle, and this is power 2. So that's quadratic in form. So now the equation becomes y squared plus 27y minus 28. Easily we can factor that. Then each y, I know it's x squared minus 3. So I can replace y here and y there. This one becomes x squared minus 4, and this one becomes x squared plus 25. This is a difference between two squares, and that's a sum of two squares, so there is an I there in the complex numbers. So all the solutions will be 2 minus 2, 5i minus 5i. These are the values of the x. If you find the product, it will be minus 100. Given the two functions, that's a normal question here. We have function f, and there is the greatest integer here, and we have function g. We need f circle g of 25 divided by f plus g of 0. That's so easy, straightforward. Take 25, replace it in g. Whatever you get the number, replace it in f. Whatever you get a number, replace it in f again. And here we know f circle g of 0 means f of 0 plus g of 0. So I replace 0 in the f, 0 in the g. Just make sure you are using the correct condition. And the answer is minus 16. Please check that. Find the domain of this function. F of x will be 4th root of x plus 6 over x squared minus 1. If you look at the index here, that's even. That means we have to make sure all these numbers here inside is positive. So the number should be positive. So we take x plus 6 divided by x squared minus 1, all greater than or equal to 0. Factor it, x minus 1, x plus 1. So the zeros are minus 6, 1, and minus 1. Easy to make a table here. Check the numbers, check the signs, and take the positive. But make sure that x cannot be 1, x cannot be minus 1. So wherever we have 1 and minus 1, we have to make them open. Everything's closed, also infinity should be open. Nice question. Given the functions r of x, m minus 1x plus 15, s of x, 5x over m plus 2 minus square root of 3. Find the value, find m, if the graph of r circle s, so we have to find the composition here, is parallel to the linear function f of x is equal to x. Parallel means the slope of this line, which is 1 here, you see the slope is 1, and you find the slope of this line and you make them equal. First, we have to replace all s of x inside the x of the function r. It looks difficult, but it's not difficult. So I replace all the s here, see all this s, I replace it there in the x, and I have m minus 1 plus 15. So I need now the coefficient of the x will be the slope here. So 5 times m minus 1 over m plus 2. And the slope 2 from the line, the linear function, is 1. So I put m1 is equal to m2, make an equation, m will be 7 over 4. This is the function. You find the value of the function. Given the function 1 over x plus 1, find f of a minus f of a minus 1 divided by f of a to the power minus 1 and simplify your answer. A cannot be 0. So this is the function. Let's find in the what is in the denominator here, f of a to the power minus 1. Separate, you see this color here. 1 over a to the power minus 1 plus 1. So 1 over 1 plus a plus 1. Find the LCD, this is a complex fraction here. So 1 plus a over a, and then 1 over that will be the reciprocal. So it's a over a plus 1. So all this, the denominator we have, a over a plus 1. Now f of a will be 1 over a plus 1. F of a minus 1, I replace a minus 1 in the function here. So it becomes minus 1 over a minus 1 plus 1. This will be cancelled. So I have 1 over a plus 1 minus 1 over a. The LCD here, a times a plus 1. So this is multiplied by a, and this is by a plus 1, and there is a minus. So a minus a is cancelled, minus and plus 1 is minus 1. Over this, multiply by the reciprocal, a plus 1 over a, cancelled a plus 1. So the final answer is minus 1 over a squared. Now 67. Simplify the expression here. We have to factor everything. And remember here we have multiplication, so that's normal. When we have division, we have to invert, change the division into multiplication, and then multiply by the reciprocal. X minus 1 up, xy plus y squared down. And then factor completely. So x power 4 minus y power 4 becomes x squared minus y squared, x squared plus y squared. This one, leave it. You see here, just leave it. It's already factored. Y squared, we leave it. X squared plus y squared, we leave it. Here, multiply, convert division to multiplication. This is the reciprocal. Here, there's a common factor, only y. Now we start canceling. X squared plus y squared This one becomes x minus y, x plus y. We can do that. And then we can start cancel x minus y, x minus y, x plus y, x plus y. The final answer, believe it or not, is y only. Now let's solve the equation. We have big cube root inside square root x minus 1 squared plus 9 minus 13 outside will be plus 2 is equal to 0. We have to rearrange it. See, take minus 2 on the other side. 2 becomes minus 2 on the other side. Cube it, because we have to remove the cube root. Now becomes square root of x minus 1 squared plus 9 minus 13 is equal, minus 2 cubed is minus 8. Take 13 on the other side, becomes 5. Square both sides. Now, remember here, there's a big mistake. If you take x minus 1 out, let's say some students might do x minus 1 out plus 3 out. That's wrong. You have to have multiplication here. But since we have addition, you have to leave it there. Okay, so square both sides, you get x minus 1 squared plus 9 is equal to 25. Take 9 on the other side. Now you can take the square root of both sides. So x minus 1 will be plus or minus 4. There are two solutions, minus 3 and 5. We check, must check in the square root equation because the index is even, and no need to check in the cube root because the index is odd. So we check in the square root, this is okay and this is okay. So there are two solutions there, minus 3 and 5. Now, question number 69 will be finding the domain of the following functions. I put here two questions, A and B, because there are little difference between them. Here we have square root of x by itself in the numerator divided by this denominator 77 minus 4x minus x squared. In B part, I put the same old expression, the rational expression, under the big radical. Let's see the difference between the method of finding the domains. Now, part A, we have square root of x, small one here. So we take all the radicand, see x only greater than or equal to 0, which means from 0 closed to infinity. Now this one, the denominator, there is no radical there, but we cannot accept any number that will make the denominator 0. So 77 minus 4x minus x squared cannot be 0. So we can factor this, 7 minus x, 11 plus x. You see? So x cannot be 7, x cannot be minus 11. Now, if we go to the original condition here from 0 to infinity, we see 7 is there. So we have to make it open at 7. But already minus 11 is outside. Minus 11 in the negative. So we don't have to count that. It's already outside. For the B part, we take the whole radicand, all of it, x over 77 minus 4x minus x squared greater than or equal to 0. And we factor this, we make table of signs. You see here the zeros, 0, 7, and minus 11. And then the final domain will be minus infinity to minus 11 open, union 0 closed to 7 open. You can check these two answers. And now question number 70, we need to graph the piecewise function. 3 pieces are there. And then we answer where the graph is increasing and where the graph is below the x-axis. As usual, we have seen many questions like this. Take piece by piece here, and then take some points from the conditions on the x, and then factor it. We can see the first one, x plus 6, is a straight line, so that's a straight line here. Take some numbers less than or equal to minus 3. Any values you can take, minus 3, minus 4, you can take minus 3 closed. This is constant from minus 3 open until 2 closed. That's constant at 4. And this is a parabola. She shifted to the right 5 units. That's a parabola. But where do we stop? X greater than 2. So I go at 2 and make it open here. See, if I replace 2 there, 2 minus 5 minus 3 squared 9. see, I know there is no equal here, x greater than, but I put 2, but I make sure I put it open. So any number after 2. Where the graph is increasing from minus infinity until minus 3 increasing, union increasing from 5 until infinity, where the graph is below the x until this point here. So from minus infinity to minus 6 open. Thank you for watching. This is the last part E of the 70 all the exams review questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. And I wish I can see you in another video with another topic. Thank you very much for listening. Bye.